What are significant figures and why should we bother with them? Ever tried to measure the sides of a box in order to figure out the volume? Probably not, but bear with me, I promise it's worth your time. Or at least a little entertaining, kind of. Well, the first thing we would want to do is get some sort of measuring apparatus, like a tape measure or a ruler. But for the sake of this exercise, let's say all we have is a stick we know to be 100 centimeters or 1 meter long. We happily measure away 12 meters, but because all we have is a meter stick, we'll have to either round up or down our next measurement depending on how much of the stick is sticking out at the end. This creates a certain amount of uncertainty in the final digit of our measurement. We know for certain that 1 comes in the tens place of our measurement. However, the ones place is somewhat uncertain due to the fact that we have to round up or down our final measurement. Now let's say Professor Stick, this guy, took pity and threw us a stick we know to be 10 centimeters long or 0.1 meters long. We do the same measurement, but now because we have a more accurate tool, we find out that the width of the box is more like 12.6 meters, not 13. Remember how we said the ones place was uncertain? Well, it's uncertain in the sense that a more accurate measurement might reveal it to be a 2 rather than a 3. Also, you might have noticed that while we were able to measure more accurately than before, we still had to round up or down the last measurement, depending on how much of the 0.1 meter stick was left hanging out the other end. So now, thanks to the good professor's 0.1 meter stick, our measurement is accurate to the ones place, but uncertain to the tenth place. So what's the purpose of all this? It's to illustrate that you can't tell people your box is 12.6 meters in width when all you have is a meter stick. The best you can say is that it's 13 meters in length, but the final digit is a little uncertain. Significant figures are just another way of saying the same thing, only a bit more refined. So what are they? They're the number of certain and uncertain digits in your measurements. Just add them up. For example, when we say there are 4 significant figures in 21.03, it means we measure to the 100th place, but we're a bit unsure about the last measurement. It's the same when we say there are 5 significant figures in 2.1038 and 6 significant figures in 840.205. Easy enough, right? Except things get a bit tricky when we have placeholders or zeros. We're not talking about the zeros in between non-zero digits. Those count as regular significant numbers. We're talking about digits that come before or after non-zero digits. Let's say someone told us they measured Professor Stick's height to be 150 meters. Unless they tell us the number of significant figures in this measurement, we won't know if they used a 10 meter stick or a 1 meter stick. If they used the 10 meter stick, the last digit 0 is just a placeholder and there are only 2 significant figures. But if they used a meter stick, they actually measured all the way to the final 0 in the 150 meters, so we know there are 3 significant figures. So to avoid confusion, if the 0 is not a placeholder, you'll have to place a period at the end so others know that the 0 is a significant figure. But what about when we use the 10 meter stick? We can't put a period after the 5 since that would be a completely different number. And we can't put it after the 0 either, since people would mistakenly think the final 0 was measured when it wasn't. So in order to avoid confusion, you'll have to use scientific notation to express the measurement. In this case, it'll be 1.5 times 10 to the second power. Notice how 1.5 times 10 to the second power is different from 1.50 times 10 to the second power in the number of significant figures. The former has 2 significant figures, while the latter has 3. The beauty of scientific notation is that you don't have to worry about placeholders when you count significant figures. Just add up the number of digits you see in front of the multiplication sign and you're set. What about decimals, you ask? Fortunately, they're much easier. When you have decimals, all the zeros before the first non-zero digit are just placeholders. So both 0.01 meters and 0.001 meters have only 1 significant figure. If you have a decimal that ends with a 0 or zeros, they all count as significant figures. So while 0.0010 has 2 significant figures, 0.00100 has 3. But for the sake of consistency and convenience, you should just use the scientific notation and write 1.0 times 10 to the negative third power or 1.00 times 10 to the negative third power. You can just add up the digits in the first part of the scientific notation and be done with it. As for how to calculate numbers with significant figures, stay tuned and find out. Stick Science.